Hello, everyone. Thank you for coming. So before we start, we should have Giovanna with us, but her flight was delayed. She will try to be here. If not, in any case, she will have a talk about RL tomorrow, just to let you know. But we will proceed as we had the presentations and everything. So we still have a lot to talk about. And we will start with some general information about the RL mission and Exoclock. So since Giovanna is not here at the moment, we will just share a couple of words about the Exoclock. First of all, I know that most of you have been in the amateur pro-am session, but because this session is recorded and will be made available afterwards for other people that are not here at the room, I will repeat a couple of things, okay? So very briefly, not a lot. So first of all, let us introduce ourselves. I'm Anastasia, Kokori, and Angelos. I'm working at UCL at the Center for Space Exochemistry Data. I am the public engagement officer for this center, and especially the area-related activities, which we are focused here with Exoclock. And Angelos?
I'm a postdoctoral fellow at the Observatory in Florence.
So before we dive into Exoclock and what it's about and how it contributes and everything, just wanted to let you know that we started this effort with Angelos 5 years ago. Everything was really volunteer and a lot of work with amateur astronomers. And now we are in a stage that we are all around the world with many participants. And this is the biggest point to highlight here, that PROM collaborations are effective, possible, and very successful, even if it takes years. So the Exoclock project is a project dedicated to the RL mission, and the RL mission The RL mission is a space mission by the European Space Agency, prepared for launch in 2029. And this mission will observe 1,000 exoplanet atmospheres. Thank you. So the PI is Giovanna Tinetti. And the mission has around, as we said, 1,000 exoplanets. And this is very important to highlight here because we want to have precise timings of this exoplanet ephemeridess, like when a planet will go in front of the star, in front of the target. And we're talking about big numbers. So this is exactly how Exoclock project was created, to contribute to this task. So the task is to make sure that we have the entire, as you see here, the entire, physically, the entire transit, instead of losing some time, because the space mission has a very important task to observe the timing exactly. So here we have half of it. We don't want to end up in a situation like that. And that's how we can contribute with the project to increase the mission efficiency, because if you have this, you lose time of the mission. We don't want that. So here we have the collective idea how the small telescopes from the ground, even very small telescopes, can contribute to this task by observing these targets in specific timings and improve the ephemeridess of all the targets. And finally, increase the mission efficiency, because this is what we want to do. Now, the project is an organized platform, Exoclock, and the main task is this: to maintain the ephemeridess of the targets. We started 3 years ago, and we aim to continue until the launch day. It is 2029, not 28. It has been updated. At the same time, the project is an effort to make the best use of resources, because there are so many small telescopes around, and amateur astronomers have telescopes, or professional astronomers have telescopes. But if it is an independent task, then how can we make the best use of resources? So we wanted to have a space where everything can be used homogeneously, because this is important. And then we don't waste time, because if you have independent people doing some things, you don't know what is going around. And after all, it was an initiative to actually connect with each other and have a collaborative effort. So in our project, it's not only about doing the ephemeridis and maintaining the ephemeridis of the aerial targets, but at the same time to bring all the people together and contribute. Everyone can contribute on a different way. So the project can be described by the 3 I's. It is inclusive, integrated, and interactive. We have the inclusive keyword because there are so many people around. We have professional astronomers from their observatories from different countries, and a lot of amateurs. So the majority are amateur astronomers, some high school students, some university students that are contributing differently because not all students have telescopes, so this is a different thing. And partnerships with different organizations and even some companies. So the second element, it's an integrated platform, which means that to make the best use of resources, we needed this element. So we combine data, not only from the ground, from different observatories and people around, but from data that are already existing. The literature has a lot of data that if you don't combine them, you don't know what is missing. And also space data for more difficult targets. And finally, the project is interactive. So this is quite important because if we have a lot of people around, it's very important to have a connection with them and also to make the process more engaging. So people can participate in the project by using material and user-friendly tools in a way that they feel their participation more active. So a little bit about each element. The inclusiveness component, we really try to make things and develop material to include as many people as possible, because when you have an experienced observer like a professional or someone that is an amateur astronomer and already knows how to do it, that's okay. But what do we do when someone is not experienced, has equipment, has all the, let's say, positive mood and the willingness to support and contribute, but they don't have the expertise? This is exactly where we created a platform, separate platform, which is an educational and supportive platform, where there are provided different things like observational guidelines, tools to understand what is going on with transits, and a dedicated software, which is this one, HOPS, and this is developed by Angelos. He will talk more about that, and just to mention that all this material can be found at exoplanet.com. It's available in different languages, so if you have an issue with English, thanks to our national contact points and other people that volunteered, we provide this material in several languages. And also, as part of the inclusiveness of our project, it is important to mention that we try to make the process educational. So we organize training sessions and workshops for the beginners, so people feel really part of this and not eliminated, that they are just left with the material and how to do it. Now, the integrated aspect. This is also something important for us because, as I said, there are so many data around how to know which planets, which targets, or what data are missing from us. And the platform integrates all the different resources together to produce the final results. So it's not only about ground-based observations. This is not enough. We have space data for targets that are more challenging and not accessible from the ground. And recently we were awarded time from the Space Telescope Cheops. So this is going to observe some of our targets. Cheops is already flying. And then we have literature data because there are existing papers and of course past papers that it's important to know what we are missing again. And finally, all the grant networks, we have several collaborations. We have our own network dedicated. The Telescope Live, which is a collaboration with Marco Rocchetto, with ETD and Philip Walter, and also with Exoplanet Watch from the US side, Rob Zellen. So we try to cover as many aspects as possible to avoid wasting resources. And finally, the interactiveness. So we have the dedicated website, which includes the platform, the database, the targets, everything related to the RL mission, but it has also a personalized account for every person that registered. So people that want to contribute, they will get their own schedule in order to know what to observe and all the details related to the targets. Then to maintain the interactiveness, we also send feedback. When a person submits an observation, we don't just review it or say, okay, give us the data, we will do it ourselves. We give them feedback and they send it back in order to finalize the results and make sure that we have both precise results, but also the participants understand what is going on. We send some monthly newsletters with updates, both for the Exoclock project, but the RL mission as well, to maintain this communication between us. We organize meetings and we have some dedicated Slack channels for several topics. So people that have a difficulty or they're doing something on the spot, they can ask to the rest of the community. And here you see an example of a light curve, finalized, published light curve, where all the details appear. Like you have, of course, you have the details about the light curve, but you have also other information like the personal information of the person that did the observation, what telescope, what camera they used, and all of these related things. So it's kind of a small publication, and every transit gets this publication on the website. Now, when it comes to our activities, first of all, we have the data integration, because we are talking about all these resources. It's a lot of different data. It's important to integrate them in a way that not only is effective way and makes sense about the results at the end, everything has to be homogeneous, but also it needs a lot of people to work behind that, because we are only 2 people. So when the team and the...
We used to be only 2.
We were 2 people at the beginning. So when it came to this point, we needed to create some things. And this is how we created the literature team, which worked dedicated, was dedicated to review all the data from the literature, because we cannot just take them. Then we have the ETD team, which was to enforce the collaboration between us and ETD, and very expert people that were using the ETD and knew how to do that. They supported with this task, so we could use this data. And then the space team that worked on space data, because they have different, of course, requirements. And then we have also some other activities which are related to practicing equipment and techniques. So these are several separate groups. One group for synchronous observations that are actually researching how synchronous observations can be combined together and produce something more like a result that is of a high quality. And then we have the CMOS observations group that is testing the CMOS detectors for transiting observations, because so far it's most observations are done with CCD cameras. So this is also quite an important task. And finally, campaigns. I want to mention that these practicing techniques equipment activities were not from the beginning. They arose from the participants themselves. They really recommended that they wanted to do something extra. And this is how we started, and they are indeed doing a lot of work on that, even though it is not the main task of the project. So this highlights the dynamic evolution of the project. We started with a main task. We didn't have in mind that we would have extra things, but this is how it goes. So the literature team, a few words, it consisted of university students. They had the opportunity to, of course, participate in the mission and become co-authors. We are talking about university students that don't have the opportunity, for example, to use telescopes because they don't have observatories, of course, they are university students, or it's very difficult for university students to have access to remote telescopes or even whatever. When myself and Angelos were studying in our bachelor, we were struggling to find such opportunities, so we're really keen on developing similar opportunities for university students. Now, at the same time, this is very important for us because these students didn't just participate, they contributed. So they had a website portal which was dedicated in order to review all the data. And you can see that there were in total 3,000 data points, which is even more, I think it's now. It is increasing. So we're talking for each data point that had to be reviewed. And very successfully, the team helped with this task. Now, the space team, this again consisted of students, either university, we even had one high school student, which was amazing, and some amateur astronomers, that they were more interested in the data analysis part. They didn't have their own equipment. So again, this was another way to contribute to the mission, even without having equipment. They were provided with a special script to analyze the different data, which were space data. You can see, of course, that the light curve remains the same pattern, but there are special things that they had to take care of. And they were also checking for duplications with the literature, so we can avoid the wasting of resources and timing. So it was very important task. Now, the final team, the ETD, again, consisting of amateurs mainly, not students, because these people were the ones that had the expertise to do that and the experience. And it was in collaboration with Philip, who supported really this effort, and I want to highlight it again, because collaborations are very important. And we spent a lot of time with Philip together to produce this. And if we didn't have spent this time, because sometimes people say there is no time and I have my own things. Yes, but how can you do collaboration if not spending extra time? So we spent that, and we had a special, again, website portal to analyze this data. Yes, please.
Just a quick question. What's ETD?
ETD, Exoplanet Transit Database,
Okay.
by the Czech Astronomical Society.
Okay.
Yes.
It's actually the most well-known database for where amateur astronomers submit their data. So it's hosting a lot of data. Philip, I don't remember the number you mentioned earlier, but it's like more than 10,000.
It's a lot of exactly. It's a lot of data, and at the same time, we wanted to both make use of them, but foster the collaboration, because we wouldn't have this data otherwise. And there are 600 data points from ETD so far, and of course, this will continue. Now, regarding the equipment testing techniques and groups that are arrived and were created for this type of activities, first of all, what is the synchronous observations task? It's the idea came from for targets that are more difficult to achieve with a specific size of telescope. So we can combine smaller telescopes to produce a result that could be achieved by a higher size telescope. So if you combine, for example, many 6 or 8 inches telescope, you can achieve a result of 16 or even more inches. So the idea was to test, because there is no much research on that. So since we have all these people around and they were willing to do observations at the same time, we had some results. We did some campaigns on that, and this is continuing. Probably next year there will be a special publication only for that. It's a by-product. It was not the first home. So maybe people that are part of that can support with the writing. So the main scope is to test the efficiency of that, of the many combining observations. And of course, the second scope, which was the main scope, is to support to the mission, like to actually detect difficult targets that are not accessible from a smaller telescope. So if you combine many observations, you can do that. And you can see here, Angelos, you want to comment on that? I'm sure it's your favorite. Yes,
yes, it is. Well, actually, this was so far is the most successful trial we had. This was this is a TOI target, so it's covered by a test, and it was in spring. Weather was good over Europe, so we had 13 observations that were successful. And here they're analyzed all together, and to my surprise as well, the quality of the data compared to other observations in our database it's close to the quality someone would expect from a 14-inch telescope. So by combining all this, they were ranging between I think 8 and 14 inches in this case. But yeah, the results were very good. So it looks like it's promising.
How many observations?
13.
13 observations, yes. And we had a
Yes.
Yes.
May I make a question?
Yes.
In these synchronous observations, this is really awesome to have 13 observations, increase the sign to noise and get the sign. But could you do it also with very long transits in which one observer is taking the observations, another one is.
That was done in the background on HD. I don't know. Do you have something? Maybe we can bring it up. It
Yes,
was
we
one
can
of
bring
the
it.
campaigns we did in collaboration with the US.
Because that would be
Yes.
another important step.
Exactly. We had an example of that in collaboration with the US side, because there was different timings that they could observe and we, and there was a
I have to say though that this is more difficult.
Yeah.
Yes.
Stitching together here, because actually it's one lecture helps the other to get the result. That's why it's increasing. The other one is a bit more tricky.
Yes, I think I have something. Otherwise, after we can show. Regarding the CMOS detectors observation, so this group, again, actually the members are both professional and amateur astronomers that they collaborate together. They did a lot of work themselves, and they were just, providing feedback and reviewing what they were doing. Not really a lot of things, but it's amazing because they even had testing. They had cameras from specific companies that they could test them for transit observation. So we are talking about real research. So the main scope of the group was to optimize the CMOS settings for transit observations and make sure that we know what kind of settings we need to follow a transit with a CMOS detector. And the second scope was to test existing cameras. As it is mentioned there were 3 cameras from QHY that they were provided by them. There are some reports written on that. You can find them on the website. And the team continues doing things because we have a lot of users that start buying CMOS cameras, or even observatories, professional observatories have CMOS detectors instead of CCD cameras. So this is again something new on the Exoplanet. Yes.
They even mentioned that they have gone even one step further, and they have produced some documents on how you can find the best settings of your camera yourself. So like how you can actually self-calibrate. Because CMOS are very nice, but they're a bit more tricky in the settings.
So yes,
you can find this on
the website. And there was also a workshop by Leon, who is an active member of the team. That this is recorded, and again you can find the workshop on the website. He gives detailed guidelines on how you can check your CMOS detector for the transits. We may have something similar very soon. In the future. So if you're a CMOS user, you can get updates about it. And yes, I have the campaigns here. So we did a campaign for TRES-1B. This was in collaboration with several people. Actually, we had our own grant network. There were observers from ETD and other places. Here, very briefly, just to say that we wanted to observe this is a target with proposed decay, if we can say it. I don't know if we have to explain what the decay is, but in any case, we wanted to track the specific target and we needed a lot of observations. So I'm not sure if it is very visible or it is shown. No, the laser is not, but you can see with the red, yes. The red points, these are the observations from Exoclock. The black ones are from the literature, and the green, I'm not sure if the green were submitted ones. So all these observations, I think they were 18.
Even more. I don't know
more.
Billy can speak up. I don't know if he still has a voice. I think a little bit more like more
yes,
than 20.
Billy?
Yeah,
right?
I think you're right. So I just about have a voice. Maybe you can hear it.
Yes.
Yeah, I think we got over 20, and I think there's been some more this year as well. So it's been fantastic to see all those observations. And yeah.
Maybe you want to comment
all
something?
these actually were acquired in a space of 3 weeks, I think. 3 weeks, something
So
like that.
pretty much the thing that we want to highlight here is that through all these observers that are under Exoclock, they were very keen to contribute to such events, special events. So as soon as we had, we raised the flag and we sent some alerts to participants, they really responded actively, and that's the result. So this proves that if there is an alert or something that we really want to not to miss, participants are around, and if you have such a great network, there will be definitely some people that can follow that. And there will be a dedicated talk about that in our upcoming Exoclock annual meeting by Simone, who took care of that, and she will present the results. And then we had another, as you can see, not many observations because there were not really clear skies in Europe at that point. So for HD 8606b, this is a very long period target, and the main, it's a quite a rare transit. So the main task was to observe the transit from different parts of the world. As I said, I was in collaboration with the US and the team of Rob Selem. There is a recent publication. Yes, the paper is out if you're interested to read about it, and there were a lot of amateur contributions. From our team, I think there were 3 or 4 observers. Yves, who is here, Yves has many observations, and he was also in the campaigns. Come on. So, yes.
With a finger in every cake.
So, yeah, very few, but even these were very important because despite the very cloudy skies at that point, it's something that was used in the results. And moving to another part of our project, we talked about how it's working. We talked about the different teams for the data integration, for the different subgroups that are working on several things. We come now to the activities that were the initial activities of the project, let's say. Apart from all these outreach activities, we will talk also about how to actually someone that is an amateur astronomer can contribute. But in any case, part of our activities is to spread the word about exoplanet science, to support exoplanet science, people that are beginners or they don't know about science related to transits. And apart from the ephemerides that we wanted to do as the main task for the Ariel mission, this was also very important. So in order to achieve this, we have organized, and we still do, activities like the newsletters, the meetings that I mentioned. We have the newcomers trainings, workshops, talks, and some articles. So for example, here you can see we have a dedicated portal for Ariel related articles. There are 2 articles at the moment. We don't want to have many because this is kind of an effort for the Ariel scientists to write something very, simply, but at the same time maintain the science. So we support the scientists from the beginning to write an outreach article that is dedicated to amateur observers. So we're not talking about general outreach, but for people that know something, but not everything. So yes, it's taking, but it's something quite nice because you can see the willingness of the Ariel speaker, the Ariel scientists, to become part of the project, and they want to come closer and closer to Exoclock and the amateur observers. So this is important. Why? Because most space mission scientists are far away from the public and from amateur astronomers. And we wanted to get the chance through the project to bring them closer. And actually, in every consortium meeting that we are attending, they always ask about Exoclock. They ask about the progress of the project and how they can actually become part of that. So we thought, okay, this is a way, but they also give talks once in a while. And it's a quite nice paradigm shift because most space mission scientists don't have this connection with amateurs and the public. Now, regarding the current status of the project, it's very nice that we talk here about the project because we started from EPSC, where we just launched the project before the pandemic, of course. We had only a couple of months, not even, live with the participants, so we couldn't travel and do stuff like that, although we had the opportunity to do many online things. So we started with only a couple of observers, like some Greek fellows. You need to mention Nikos Paschalis, who supported in every scale our project. And then gradually, people became aware of it. They really liked the idea of having a community and contribution to a space mission where we all do it together. It's not that we do it or we just grasp their data. So I really like the thing that we are all together a community. More than 600 participants. You can see that the majority are amateur astronomers. So this again highlights not only the willingness of these amateur astronomers, but also the amazing things that they can do for the mission. More than 4,500 observations. There are around 600 telescopes registered, and people come from European countries mainly, but you can see that the map is extended to other places because we have enthusiasts from other places like Taiwan, where there is a whole group dedicated to Exoclock in their university, or even you see in the US and other places. And the targets that have been observed so far out of the mission reference sample are more than the half, 375, which means that there are a lot of targets of the candidates, okay. Now, I'm going to show you a little bit about the process itself. How can an observer from 0 point, let's say, navigate through the website and actually become part of that? And of course, if you have questions, you can, it's an interactive thing. And the main idea of that was to actually get your questions. So we start from the target list. As soon as someone has registered at the project, they will have access to all the portal and all the different features.
This actually, no, this is available to everyone. It's even before you sign up.
Yeah, but I was going to talk about the scheduler, but the personalized scheduler, yes, of course.
This is for the whole community to have an idea how the project is going on.
Yes, so you can see all the different targets that are at the moment, and they are aligned with the Ariel mission. They are all the targets that are selected as targets for the mission. These you will find them here. So it doesn't include all exoplanets that you can think about. It's specific targets. Okay, here when you click, is it visible? Okay, there is a priority, saying some priority. Next to each target, there are different information that are useful to plan your observation. So priority means that we want to, let's see, yes, here. So when you click the priority, it will show you these different color coding words. So medium, high, low, or alert. And these are all designed specially to make sure that an observer will choose the best target for the night. Because if it's a low priority target, that means that we have enough observations for the moment, so they don't need to observe this specific planet. Medium means that there are fewer observations than low. I'm just commenting it very briefly. It's, we have set some targets, some target limits for that. And high priority means that the target hasn't been observed for a long time and needs an observation. So an alert means that definitely go and observe this target. But this is quite helpful for the observer because when they will have the whole list of the targets. If it's say 10 or 20 targets, they don't know which one to observe. So by pressing to the priority and knowing which priority it is, they will give priority to these targets. It's very efficient in order to choose, because we have heard many times which one to choose. Just go with the priorities.
Although a word of warning is that, especially for beginners, if there have been few observations of a target, it's probably because it's a difficult target, And therefore, generally, if you want to start with something easy, you probably don't go to the high priority because high priority are difficult.
That's a good point. Actually, in the beginning, this was happening, but now it has naturally it has been settled. So the transit that will appear in the scheduler, you can do it. And there's no problem if it's a high priority.
Yes, but that's a good point. We usually recommend to the beginners to start with.
I will comment on that later.
Yes, okay.
When I talk.
So yes, if you're an amateur observer, astronomer, either with a lot of experience or less experience, and you like exoplanets, and you want to be part of the mission, okay, it's two prerequisites. Otherwise, why you should join. Sign up. You can use the sign up sign there, as you see, and then you have your personalized account. And you will have access to several features. So here you will see a portal. There are many things, but there is a portal that is called Material. And this is where you can access to all past meetings that we organize. So we do monthly meetings and sometimes workshops, as I said, and other kind of trainings. And they're all uploaded straight after the meeting, in order to make it available for people that couldn't join. And they have a lot of use because indeed people cannot join every time, and it's helpful for them to keep up to date. And then we have also the newsletters, as you see, one for each month. And then people can also get an idea of what things have been done in the project, or if someone missed it in their email, they can access it here. So everything is collected together. And also we have the Slack channels, I mentioned that, which is important as well, because even though meetings are nice, you can maintain everyday communication between the users, and Slack is a way to do it. Then, as soon as you have signed up, you can register your telescope by using Yes, yes, you're right. I'm not sure if it. Okay, yes, you can go to your telescopes, register a telescope as it is shown here, and insert the different details and everything related to your telescope. You see the size, the observatory, latitude, longitude, the name of your observatory, and you can yes, you can even set the horizon limit, because not every place has the same, and every observatory the same horizon place. This is important because then the scheduler will know which targets will give you, or give you a sign that, for example, you may miss the beginning or you may miss the end of the transit. So here you have your telescope. It is appearing on the map, as you see.
Always advise users to check, because there are many observers with telescopes in the middle of the sea.
Something.
Check where it is.
Okay, I think it's done. Yes, so you will have your telescope registered, and then you can directly start. Yes, here. So you can go to the scheduler and see which targets you can observe. The system will have prepared for you all the targets based on your latitude and longitude, and based on your telescope size, because this differs. Of course, the horizon limits that you have set. And here you will see all the different targets that you can observe. There are some details here. I'm not going to.
I will speak something.
Yes. But this is pretty much the process regarding the scheduling. Now, what do you do when it comes to the actual observing session? You have your target, you know which target you are going to observe. You go, if you don't know how to do it, if you know, okay, that's fine. But if you don't have the expertise or the experience of how to observe an exoplanet, you visit the separate portal that we have here, the ExoWorld Spice. By clicking for observers, you can get all the different guidelines. And here it is, like you have the setup and some, it gives you direct guidelines on how to do it, simple steps. And if a participant has questions, they always come back to us, but usually this is enough, even this is enough for them to do the first observation. And then when it comes to the analysis, how to analyze the data, there are software around, more, let's say, dedicated for specific observatories or whatever. And we decided to have our own because we wanted to maintain the validity in the results, but also to make it simple and easy. So the task was to have quite, let's say, as Angelos mentioned the other day, scientifically not simplistic, right? Yes, not simple, but to be user-friendly, but at the same time to produce the high-quality results that we wanted. So this is HOPS, and there is it is a software that is available on the website. It is free, open, and you can download it. There are manuals in different languages, and install it and start your analysis.
Also some videos on how to use it.
And then the next step is to, after the analysis, to upload your observation to the portal in order to be published. So first of all, as soon as you have uploaded your observation, I will skip that. You upload your observation and you see, this is the thing that you will see. You see some evaluation reports that accompany the light curve. And this will help you proceeding with the light curve. For example, there are some signs, indicators, and if they are blue, it seems that they are all good. If there is a green, things can be improved. If it is red, it means that definitely something went wrong, so you have to reanalyze. Even after this evaluation report, you get your self-guidance, but then we have our team that will do the further review of the light curve and give feedback or just publish it if it is okay. Many times the light curve needs improvement, so this is where the reviewing team will send feedback to the participants in order to improve the data. Sometimes we even ask for the data in order to see if there is something wrong there. So it's a really like educational process, but at the same time, we make sure that the results are precise. And this is the final light curve that will appear on the website, but also in the final publication, you will have each light curve for this. It's light curve for each observation. And the new thing that we're starting this year is a collaboration with Las Cumbres Observatory and Telescope Live, where there will be access to remote observatories for people that don't have equipment, like some general, we had some people so far that they supported the mission, although they didn't have telescopes. And it's a great opportunity to expand and include more people. Then we close here with the announcement of our upcoming meeting. We started last year, we did the first annual meeting online, but this year will be live, in person, and remotely. However, if someone is not in London, can attend online or spread the word, because it's a great opportunity to hear about other aspects of the project that we don't have time here to talk about. And some very nice talks by Ariel speakers, guest speakers. So definitely spread that with other people, because it's something that it helps them getting closer to us, and we can know who is around and interesting. Okay. Yes. I think that's all from my point. Anders, we can move.
I think maybe if there are questions, we can do it now.
Yeah, I don't know if you have questions here.
Something you want to discuss, ask about more specifically, because then I'm going to present you the latest publication which appeared today. Actually, we put it online. So yes, and we will go through and explain the current results. Actually,
we'll talk
so
about
it's a good point to split the thing. Yes,
yeah.
Either because I'm here or it's obvious. Colleague of Charles University spoke about the network of the unistellar in-scope telescopes, and you launched an initiative to not like possible to combine the individual light course. So I think those things are like probably.
Yes, you're right. Actually, we have some participants, especially from France, that are using the scopes. But I think they need to do something special with the data analysis process. It's not as straightforward as what we explained here. I think that the data are processed by them, but the scope not. But I don't know exactly.
Yes.
But Anna has produced a small document that explains how to do it. So we get participants who can contribute to Exoclock with the scopes.
I once tried to start making some observations. I prepared everything for the night, but I didn't know what went wrong. I think it was cloudy.
Well,
But the question is, do we, the methodology is the same as observing variable stars? That means we take the Fritz files and then through your program is processed the
or whichever program, there's no limitation. You can do your own analysis and then you upload your light cube. So the website takes as input only a light cube.
Yes.
So it is true that we have also developed the code and the educational material platform, but we try to keep everything separate so that people have the freedom to do it their own way. So the point, I think that the point that combines all of them together and make sure that things are working is the final evaluation and the review. So
Exactly.
yeah.
We
If
get
they agree with everything, everything is good. It's good.
Yes, we have observers or professional astronomers that they use their own software. For example, their
And
observatory.
if he's
It's-
using minimum,
It's because I'm lazy.
you have your routine. That's not
Exactly. Some people
problem.
have their own.
No, I'm using MiniWin, which is a non-fee package.
Well, when there is a newcomer, we strongly recommend them to use HOPS. But we had also some amateur astronomers that switched to HOPS because they were willing to learn something different and wanted to do it in that way.
I will highly.
Otherwise, it's the same.
Yes.
The same.
It's the
process.
same methodology. One more question arises from what you said before. So is there an option that I can produce the Fritz files and someone else makes the measurements?
Makes what?
The measurements.
Oh. No.
Shall we create this group?
Oh yeah, I'm
Yes.
sure that people will be willing to
Yeah.
analyze data for you if you don't have the time.
I'm sure there are people because we have received several, requests by people saying that I don't have telescope, but is there any, are there data that I can do, or they want to contribute, they want to learn to be useful, and yes.
It's a good idea, actually. It's a very good
It's
one.
a very, for me, I don't have time to save the planet, but I can look for my telescope running for one night, but I don't have the time to analyze the data.
Yes, yes, definitely. That would be great.
Here
Actually.
for you. Don't worry about that.
Yes, Georgia and some other people this year, the last year, we started with some time that we were using from Las Cumbres Observatory. So we had around 10 people that they just used, yes, they didn't have the telescope. So this target group definitely would be willing to do that.
And I think also this year we will do it in a bit like the Europlanet telescope. So I think that we will ask some people to propose some targets, and if the proposal makes sense, then we will give them the LCO time to do some observation.
Because we have this time.
Keep
but-
us interested.
Exactly, but we want to make sure that the participant that joins is indeed interested, and not just not
More like an educational.
yes, and to do the process, like to understand that you have to schedule the observation. It's the whole thing. But if there are already observations, as you say, that you upload, this can help also them understand the process because they will have to download the data, process them from that point. Yes.
Thank you.
I have one more question, but
No.
you have no time.
No,
I mean,
we can
actually,
ask.
we have a lot of time because you
Ask the question, then
are.
Alex will present some of the results, which is also interesting because you can see actually what we were producing. Not
There was a strong conversation a few years ago about how easy it CMOS cameras. And I see you are now have a group specializes on it. So you take results with CMOS cameras now.
Yes, there are quite a few observers that submit results with CMOS and DSLRs, which are using CMOS. Yeah, there are some caveats here and there, but it is possible.
Yes, for one caveat is, for example, the processing.
Yes, actually, yes, I had to develop new features in order to make it work. So I will publish it next week.
Yes.
So it should be available next week. For CMOS are separate because the analysis is slightly different. But yes, I mean they do have the precision, and if you are careful with the setup and with the reduction frames, the results. Well, however, I need to say that I have seen that the quality of the results ranges from extremely bad, like the worst thing I've seen, to even the best thing I've seen. So it's a matter of settings. So the observer has to learn his their equipment, understand how it works, understand the best settings, maybe even change the best settings per night, depending on the target. It's slightly different. So I'm not sure it's so straightforward like CCD, but personally, I'm convinced that I'm going to buy a CMOS camera this year and I'll try it again because they are much cheaper as well. So I will do it. I think many people are tempted to do
Yes, and next week, for those, if you know CMOS users that would like to know, there will be a workshop by Roland, who is really expert on that. So it's a unique opportunity that we will have him, that will present all the results and will give some guidelines. And I think it's a good opportunity for CMOS users, even if they are not observing exoplanets, to get an idea, an update on CMOS cameras and what the capabilities of them are.
So actually took these 3 cameras as long from PHY, they put it in a test bench and they tried.
There will be also, actually, they will be invited from the camera companies. They will join us. So I think for CMOS users, it's a good chance to get some more ideas and knowledge on that.
Yeah, and also the comment for CMOS cameras is that they have 0 overhead. And it's actually, it's very important, we will see later, for the overall signal to noise ratio you get from the transit, because for us, it's not about the signal to noise you get on the star, it's about the signal to noise you get on the transit to the whole observation. So the dead time between exposure is very important. If you make it almost 0 with the CMOS camera, then practically you can have small telescope into the same world.
We keep discovering, well, tools, I would say telescope in orbit keep discovering new exoplanets. So the number of exoplanets is increasing with time. The number of aerial targets will not increase, because I was wondering if
Billy, just wait. Billy, are you here?
Yeah, I'm here. I heard aerial targets and my ears perked up.
Billy, maybe we didn't actually introduce Billy. He
Yes,
was
sir.
supposed to be here, but unfortunately, he got COVID. Huh? That's right. He's the other coordinator of the team.
Yeah, we are 3 actually.
But Billy is more responsible for the space data. Yes, maybe you can comment on what was the question?
Can we bring him maybe on the screen?
yeah.
Billy, if he wants to.
Oh yeah, if you want.
You want to just
Oh yeah,
introduce-
I can turn on my camera. I can even show you how close I am to the venue.
He's here.
He's in a hotel across the street.
You guys are literally there. But yeah, unfortunately, I'm stuck here. Today, my voice is just completely gone, so I'll try and keep it kind of short, my introduction, I guess. But yes, hello, everyone. Sorry, I can't be there in the room with you. Yeah, as they said, I'm kind of in charge of the space side of things. My main contribution, I guess, has been looking into the target list for aerial, so the potential targets that we're going to observe with the mission, which of course are then feeding into Exoclock and being the ones everyone's following up. So yeah, that's been my latest work, I guess, related to that. And also there's the we had lots of KEOPS time awarded earlier this year. So I think a few of those observations have been taken, and they're going to be taken sort of over the next 12 months as well. So there should be some nice data coming from that. So yeah, looking forward to that. And yeah, if you can repeat the question, and I'll happily try and answer whatever it might be.
I have noticed that over the last year, the number of targets that were part of the Exoclock effort have increased. You know, targets were added in the catalog. And I was wondering, you know, Ariel will be launching 29. There will be a lot of additional exoplanets discovered. Does it mean that the number of targets for Ariel will also increase, or the choice? You know, what makes that an exoplanet is a good exoplanet for Ariel research or not?
That's a really good question. So yeah, I think so based off at the moment, you know, the ones that have gone into Exoclock are only confirmed exoplanets that we think are good targets for Ariel. So they are those that we could get to, you know, we've got this 3-tier survey. Hopefully most of you know what that is, and Giovanna can come and explain it soon for the rest of you. But getting to the tier 1 requirement after 5 observations is kind of the cut that's being placed at the moment. But the main mission that's really providing targets for Ariel is TESS, which is still ongoing and observing the whole sky. And when we recently looked at the planet candidates that are coming out of TESS, so these are you know, signatures that look like a planet, but they've not yet been validated or confirmed. It's suggesting that, you know, if all of those were confirmed, which, you know, they probably won't all be, but hopefully a vast majority will be, we should be somewhere in the region of 2,000 targets that are potentially good for observation with Ariel. So as you mentioned, yeah, that the question of, you know, if we have those 2,000 targets and how many of those can we actually go and observe? We did kind of look into this a little bit as well. It depends on like our priorities. We have this, you know, tiers, which are kind of increasing in detail as we go up them. So how many planets you observe in each tier kind of defines how much time you're spending on that. So we could do more planets, for example, in tier 1 and then fewer in tier 2. So do lots of planets in less detail and then select fewer to go kind of really in depth. Or you could do the opposite and try and go for as many planets as possible in as much detail as possible. So I think this is going to be a, you know, a kind of question that we're trying to answer as a consortium going forward, and will depend on, you know, a variety of factors. You know, at the moment, to say a target is good for Ariel, it just has to be confirmed and then meeting our signal to noise requirements. But I think there's definitely going to be things like, you know, for example, are the ephemerides good? Can we trust that when we point Ariel at it, there will be a transit? You know, that's the point of Exoclock. But there's also making sure we have the planetary mass, maybe, or good knowledge of the stellar host. So there'll be all these other additional requirements which kind of come in. So what we're hoping is that, you know, we can get this biggest catalog as possible of potential targets, and that the only reason that we narrow that down is because we've decided to, you know, select targets for getting the most diverse population for Ariel or something like that, that we're not cutting targets out simply because we don't have enough information. So that's the kind of hope and the goal, and that's something, you know, Exoclock is really contributing towards. But it's you know, a huge effort and something that's really going to need to carry on right up until launch. So yeah, potentially we could do more than 1,000 planets. We're already starting to think about what would happen if we had an extension to Ariel. There should be enough fuel on board to go for another 2 or so years. So we start thinking about that as well. And again, you could do more planets or go back and revisit the same planets and see if you see changes in time and all this sort of stuff. So I think these are all still open questions and very good ones as well. So yeah.
Thank you. Well, there is hope, because if you look past satellites, they have had lives that were much longer. You know, if you look at Juno, if you look at Hubble, you know, their life is much longer than what was initially thought. Let's cross the finger for that yet.
Yeah, so the key constraint will be fuel to stay at L2. But as has been seen with JWST, you know, they were expecting only to do maybe 5 to 10 years. Now they're expecting the fuel maybe can last 20 years or more. So we can always hope for Ariel that we get a perfect launch. You know, we'll be using not the Ariane 5, but the Ariane 6. So hopefully that gives us an improved, you know, budget in terms of fuel. But I guess we'll just have to see and cross our fingers.
We have to continue now.
Yes, thank you, Billy. Even though...
By the way, we already have extra 50 planets that will be added in the next few days, months. So yeah, these were over the summer. So they will be keep increasing. I will find it. So let's have a look on the results, and I will try to be quick so that we can discuss. But by the way, I prefer if you have questions to ask them as I speak. Just raise your hand, no problem. So we play. It's a bit in spines, but
before
I will find it. Okay. Yes. It's okay. Good.
It's not predicted here.
It is.
Oh, this, yes.
Yes, it is.
Sorry.
Good. Okay.
Just
So
to mention that for this particular part, which is the results, this is we organized that to be coincident with EPSC, the press release. So we will have a press release on the specific paper because it's the largest publication we did so far, not only in terms of co-authors, but also in terms of the work that has been done. So Angelos will elaborate a bit, but please ask questions while we are presenting, since we are all here. Yes.
thank you. So well, actually, practically, I say that this is the complete view we had for Exoclock from the beginning. Okay, we had to wait 3 years or so, 4, to get to that point because it was actually a lot of work. But what has been put together at the moment is really what we envisioned from the beginning. Because now we have also put together data from space and more from ETD. I hope that we will add even more in the future. But now we have all the tools and infrastructure that we wanted to have even from the beginning, but it took some time to develop. So the paper is, well, it's very close to being accepted. Probably it will be accepted in the next few days, but it's been recommended for publication. So I think it will go through really soon. And well, the most difficult thing for this paper was to write down the names of the authors. I had to write a script to do that because at the end I couldn't do it manually. It's non-sustainable anymore. We are more than 200 co-authors here, and yeah, this number is growing. I projected for the next year and was terrified with this. I saw a number like 370.
Just to mention that
worse.
we have at least 5 co-authors here. We have.
Do we?
Yes.
1, 2, 3,
Lawrence.
4,
Lawrence
5,
Ricard, Mercedes Correa,
6, 7, 8, 9.
Yes, which is great. Half of the room.
Yes, and for us it's really important, as I mentioned, to acknowledge the contribution. So here are all the people who contribute either with observations or with support through the literature team, the ETD team, and the space team. So the scope is the known one, to produce the catalog of ephemerides, and in this paper we had ephemerides for 450 planets. Sorry for looking at the screen, but I cannot really do that all the time. So no, it's fine. In total, from all the resources, we got around 18,000 data points for these 450 planets. And as I said, the co-authors, there are more than 200, and the amateurs that contributed with observations mainly are on the order of 160. So it's mostly about amateur astronomers. So yeah, the data sources are space. So at the moment, we only included Kepler, K2, and TESS because Spitzer and the Hubble, which we also have in mind for the future, they're a bit more complicated in the analysis, and hopefully the space team of this year will help us. And also we will add cubes, but at the moment we added only Kepler, K2, and TESS. I shouldn't say only because you see it's already more than 12,000 light years, but basically because Kepler was just operating for a very long time. The literature data points are about 2,400, and then we have the ground networks, which is our network and the synergy with ETD. Light years from ETD are not many because it took us a lot of time to develop the framework, but now that we have the framework, I think next time will be a very, very big number. So the table here summarizes what is going on, but I will show you 2 plots to have 3 plots to have an overview of the contributions. So here is the distribution of the data from our network as a function of the telescope size. So you can see that most of the contributions are with telescopes that are this huge peak, it's Eves, sorry, it breaks the nice uniform distribution that we should have here, because I wanted to highlight, maybe we should normalize or remove Eves observations from this plot, because I wanted to highlight that telescopes from 6 to 16 inches, they are more or less contributing equally to the database. And then the really big telescopes that are above 20 inches, they are mostly complementary for some more difficult targets. And I think this small peak here is NL. But otherwise, while we have telescopes up to 40 inches in the network, they are not the most active ones, as you can imagine. And this is one of the reasons we started the project, because these telescopes, they don't have so much time. However, the small telescopes, they have more time. So we really the results were based on the smaller telescopes as far as the ground is concerned. So you will see quite a few diagrams here, but this one shows you the distribution of the uncertainties. So when you do a measurement, you say, I observe this target at that point, and you always see in the OC there is an uncertainty, so plus minus 5 minutes, plus minus something. Most of the observations that we have in this paper, they have uncertainties that are definitely less than 10 minutes. And I think I had the averages on the previous one. Maybe if I go back. Yeah, so the averages are close to like 1 minute. So the way that the scheduler is working and suggesting the observations, we get very good signal to noise, and also the filtering that we do later. So that, of course, with ground-based telescopes, we get only the good ones. So we're suggesting the good targets, so the difficult ones are for the bigger telescopes. So overall, this shows the quality of the data that are in the database. And then we have another interesting plot, which I need to explain. It says coverage vs number of planets. Yeah, so coverage actually means for how many years these planets have been observed. And you can see that if we take individual cases, most of the very few planets have been observed for a long time. So 100% means that we have an observation from each year since the planet was discovered. 10% means 1 in 10 years. And you can see that individual sources, they don't really do it very well as they are like alone, but putting them together, and that's why we're putting all of them together, actually the coverage is increased by a lot. And again, the scheduling activity and the prioritization system that we have helped us do that, because instead of focusing most of the effort on very few planets, the scheduler, the way it works, actually supports observing a wider range of targets. So as Yves said, if a target is not observed, has never been observed, it will be high priority. So someone will observe it at some point. It's red. So the overall coverage has been increased, and we see something like 50% to being the average. We hope to bring this curve all above 50% at some point, because then we will be sure that everything is working well. We will have a good baseline. And we hope that next time ETD data will help a lot with that. Now, this plot here shows the uncertainty. So let's say how good the ephemerides are now, updated, versus how good they were before. So this diagram here on the left-hand side is the same. Yes, on the left-hand side, you see a comparison between Exoclock 2 and Exoclock 3. The dashed line means that they are the same. So it means here that from Exoclock 2, we have slightly improved. Not too much, but there is a level of improvement. And actually, this is a very good point for us, because it means that even the ephemerides we had produced with less data, they were good enough. Now we can improve, but we didn't have any huge surprise. On the other hand, if we compare on the right-hand side, if we compare the ephemerides we have now with the ones that we had when we started the project, we see that almost all the data points are on the right of the curve. Which means that there's been some improvement, smaller or less. The stars are planets with TTVs, which okay, you don't take into account when you compare the ephemerides, because they're just moving around. So we have a few categories of planets, and I will show you some OC diagrams later. So significantly improved drifting, or the alerts, as we used to say in the website. Improved ephemeridis, so ones that are now better than before, but not so much. Ones that did not change a lot, and the TTVs, of course, that we have introduced now. So you see that compared to Exoclock 2, the no change is a big percentage, and that's what we are happy about. And the significantly improved are 0. Means that there was no significant improvement between the two papers. There was an improvement, and mainly wider sample. But again, if we compare it with the initial ephemeridis, the numbers are, so you see 30% are significantly improved. Overall, if we add the two first categories, these are the ones that really we need to update. Meaning that if we don't update them in 2029 or 2030, we will lose them. So these are the two first ones are the ones that need to be updated. So very quickly, this is a something's not showing up. There used to be the, okay, so yes, there should be a gray one here, but anyway. So the dust lines is the previous ephemeris, and which was very uncertain. That's why you see it's like widening a lot. And the blue one is the target. This is how well we want it to be. Now it's not showing. Why is it not showing the? No, it's not showing any of them. Anyway, you can imagine that here there is no. Here there is a line at 0, which is the current ephemeris, which has been improved. But the previous one was like here. It was I think it was a highlight of last year. So cohort 11, where there was a 2 hours drift that was observed, and that's because this planet was not observed, happened not to be observed for many, many years. So the transit came at a completely unexpected time. So this is an example of what we call drifting. So 30% of the planets doing that is a quite important percentage when you want to plan thousands of observations, because Ariel will observe 1,000 planets, but to get to 1,000 planets, you need many thousands of observations of transits. So we're talking about a really important feature in the scheduling. Improved is something like that. So it was already okay, but it's getting better. No change is really nothing has happened, and no change mostly are where not many data points were added. And then for the first time now, we have introduced the TTV flags, because we saw a lot of interesting features, cases that we know actually that the planets, either they have TTVs because there are more than one planet in the system. So K219b on the left-hand side, it has a companion, it's planet C, and that's why these variations that you see, they are real actually. So the transit is coming later or earlier, depending on the interaction with the other planet. And on the right-hand side, you have a very famous planet that we know it has TTVs. Actually, it's not TTVs because of a companion. We know that the planet is decaying, so the orbit is becoming smaller and smaller, and the planet at some point will fall to the star. So you see this nice parabola with the green, we have the space data, with red is the Exoclock data, and the black is the data from the literature, because this one is a planet that has been extensively observed. We just continue, and the more data that have been added, the more physics that we can extract from this kind of curves about the interaction between the planet and the star. Oh yes, we had also this case of the Qatar 1b, which actually I tend to mention because this is when I started doing exoplanets. Everyone was observing Qatar 1b because we were not sure if it has TTVs or not. By eye, of course, you don't see anything, but by performing a analysis on the periodicities on that, this time we find something, and it's a single periodicity which is a little bit more than 1 year. So we don't know yet what it is, but we hope that by building more and more observations, we will get something. So maybe Qatar 1b in the end has some TTVs, don't know what is causing them. And I think there was also another publication recently suggesting that. So I think we're getting there finally, that probably there are TTVs on Qatar 1b. So another thing that we could do with all this data is actually to calibrate the whole network. When you go to your schedulers, it tells you if you can observe a transit or not. This is not magic. So the calculations are being done. In the beginning was based on theory. Now it's really based on data. So this curve on the left-hand side is a comparison. So you see the R magnitude on the horizontal axis and the noise, normalized noise of the light curves, normalized to 1 second and 1 inch. So you see how nicely this goes up. It's natural that it goes up with magnitude, but we don't know, without the observations, you cannot really do that. So if you want to calibrate your instrument, you need to take some observations. It cannot be calibrated by itself. There is no fundamental equation that will fix that for you. But with this kind of observations, we can now know what kind of noise we will expect from any kind of telescope. Let's say the average Exoclock, we can imagine an average Exoclock telescope. So let's say that you register a 10-inch telescope, and by that we can actually know more or less what kind of quality the data will have, depending on the magnitude of the star that you observe. The other curve is for TESS. Okay, of course, TESS is much better, so I'm not going on observation from TESS is better usually, but it has the same principle. So there we did this for both, with both the Exoclock network and the TESS. And so in the paper we present, so this is just an equation, an empirical equation where you can calculate the minimum telescope necessary to do a transit. It includes some numbers that were fitted on the data because it's empirical. And so the R magnitude of the star, the transit depth, the lowercase d, and the duration of the transit. So T14 is the duration of the transit. So by taking this all into account, you can calculate the minimum telescope needed. And in the new scheduler, that's what I mentioned earlier, you will find this feature here. No, pointer. Here. So in your scheduler now, you will see the minimum telescope required to do an observation, and you can choose yourself which one is easy and which one is not. So now maybe the newcomers, they can actually have a look on that. So if you see that the minimum telescope is 5 inches and your telescope is 11, as in this case, it will be easy for your telescope. Also, if the observers will notice at some point that here, up here, there are two sizes. So one is the 11 inch, the one that you give, and the other one says 10.33. This is because the observations that I have submitted to Exoclock, they were not up to the standards of an 11-inch telescope. They were a bit worse, weather, camera. So the scheduler has degraded my telescope as 10.3 inches. It thinks that it's not as good as the average Exoclock telescope, and that's why it will give me targets that are for a 10.3-inch telescope and not 11. So the more observations that you upload, the better this estimation will be. So if you are for example, in a city with with a lot of light pollution, this number will go down a lot. Or if you are in a very good location and the sky is perfect, then this number will increase, and practically your telescope will be thought to be larger than the actual one. I think if you are about 1.01, because maybe you set the average, I don't know. But yeah, so most of the observations are actually in the end, most of the targets, most of the telescopes are around 1. So this gives us the average. Yes.
I have a slight disagreement, because this gives the impression that the brighter the star, the easiest is the measurement. And that's not the case, because you have to fight with the saturation of you.
Well, actually,
and then you have to take many short exposure, and then there is a download time.
That's why we always That's why we always say that the exposure time, even on the website, the instruction are, if you need the exposure time to be very low, so your overheads are more, don't do the observation. So in all of these cases, it is assumed that in the worst case scenario, the download time is equivalent to the observation. So 1 minute of observation, 1 minute of download, it's okay. But if you do 1 minute of observation and 2 minutes of download, then it's not feasible. So this should be taken into account. Yes.
Yes, I have a question. Here, the shown transits are selected also by our president uploaded observation, the quality.
Yes, so if you are a new observer, this cannot be done, but with the more observations you add, then the results are taken into account. This is to adjust based on your sky, because
I'm asking because I'm providing some transit times predictions for some summer schools. So
okay.
I put a new telescope between the
Yeah, so the new telescope will be exactly the, as you said it, if you say 10 inches, it will be 10 inches.
So I get everything like possible.
Yes, exactly. No, there's no change. And based on these calculations, we can actually do, and I will close with that, we can do an expectation of how many targets they can be followed up with our network, and so and tests. So there is an overlap mostly, but in total we reach a number of like 95%. And I have this plot here with the last one, which shows how many targets can be observed as a function of telescope size. You can see that even with 5 or 6 inches, you can do more than 30% of the total sample that we have at the moment. Up to 60 inches telescope, you do 70%, and then the larger telescopes, they contribute a little bit more to reach to about 85%. This is only for Exoclock. And then if we took also tests into account, this goes up to 95 or so. So yes, the prospect is that we can do most of that.
Yeah, so the main message is that the
It's working.
Yes, the combination of all the data that we are using allows the successful follow-up of the aerial targets. And of course, the whole idea of the project was to identify the gaps and fill in the gaps by using the observations that we have from the follow-up, from the current Exoclock network. So in this process, just to wrap up, in this project and process, we are inviting all amateur observers or professional observers that want to be part of the mission to, of course, sign in or just join us. And this is kind of a follow-up process. It's a long process. We started 3 years ago, but it has to continue until the launch date. So definitely we will have some really passionate members that will. But we are happy and we would like to have new members because it's something that is ongoing. And as you realize, it's quite a dynamic thing. That's why we would like to have more people because we will have also more ideas and more things to bring.
Yeah, actually, we'll go to one even now.
So thank you very much for joining this session. A few reminders. First of all, tomorrow Giovanna will have given the same exact talk as here.
Okay.
So please join it if you're interested to learn about AREL. And you can ask questions here at her talk. She already told me that. And secondly, you're all invited to join our annual meeting, which is happening in 1 week from now. Of course, remotely, it will be live streamed, and there will be more details and opportunities for discussions for several topics. Spread this with also maybe university students that we know already there are several students that want to be part of the mission or other amateur astronomers. So with that, maybe
we didn't do the workshop on hops, but I do this now every month.
Yes.
So you will have the opportunity if you're a newcomer to join in one of them. It's like, and it only takes 10 minutes. So if someone is really interesting, I can show you outside.
Yeah, and maybe because we don't want to take time. For
I would
that
prefer
later.
the discussion. So it was
We
much
will
better
have-
the discussion
yes,
we had
exactly.
rather than hands-on stuff.
If you have any questions, you can ask us after the
Is the other next session starting
happening
now?
Yes.
We have half an hour between sessions.
Okay.
Okay, so we can have some discussion.
So we can have now some questions if you want.
So yes,
Or do you want to start earlier? I don't know.
it's up to you, Ricardo. You let us know.
I have to update 2 slides before the next session, but otherwise.
Okay.
Good.
Okay, any questions then? So
Yeah,
since we have some
and
time, but then
maybe-
we need some break.
Something based on your probably interest, because we have a lot of different people joining. It's not only amateurs. If we would give a demo on hops, that means that we had.
Yeah, we don't do anything
beginners.
else. But if you want to have a discussion or talk about something you want, any questions, ideas?
If I can say something, it's just that I'm really impressed about how we have been able to carry on this project in such a short time. I remember the first time that we spoke in Berlin when
Yes.
we were working on HOPS, and then in Geneva. And now it's like an explosion of collaborators and credible observations by people that are able to.
It is true that the
hundreds and hundreds of hours tonight to get this data and then do the science for the pictures.
you said the word credible, and I actually would like to stay there because at the beginning we recently, well, actually very often we were asked, do you really trust this data?
Yes, at the beginning,
I think it was the main question, like all the time, and say, well, I cannot really say. The best thing that we can do is to provide all the information, provide the training, and then we will evaluate the results. And that's what we're doing. And practically, I think in the end, it's not only that it's not that we are keeping the best of the data that we receive. In the end, I think that the big community has been trained as part of this process, so they know better how to do this. And many people have said that already. I remember, in the beginning, most of the observers were struggling to get the blue colors in the light cures, like everything was red. And we had spent a lot of time to help. But yes, I think now everything is credible just because of interaction. That's the point.
And also you mentioned that you remember in Berlin, indeed, it was 4 years ago. Yes, 4 years ago. So you really followed up the whole progress of the project from the beginning until here. And I just want to say that at the beginning, professional astronomers, especially, like people who were working on exoplanet science, they were not really encouraging or trusting this. So we had to fight with that. And that's why I talked about the paradigm shift, because in the beginning, the professional astronomers would say, why should they trust this? Or how can I know? It's more time for me to spend. And we were going to specifically professional.
It's true that it's more time at the beginning, but now it's not.
We were going to professional conferences just to try and discuss that with them, just to show them the different perspective. Now that, look, we have a few observers now, and these are the results. If we do that organized with some protocols and homogeneous, it may be different. So they are now starting thinking differently.
There is a proof of concept.
Yes.
Like the potential is there. You have to put something yourself. If you want to get something out, you have to put some time yourself. As I mentioned I think yesterday, if you are the one doing the analysis, it's your responsibility to give the tools and give good tools. In theory, these are the tools that you're using yourself.
And it's still many years before a year, so plenty of room to develop this further.
Yeah, well, if we have 50 new planets every semester, it's going to be a problem. We need more. We will need more people to follow up, and we're missing like a lot from the southern hemisphere at the moment. There is a question online, if you don't mind.
Yes, let's.
Hello.
Oh wow, nice. You have a question?
No, that was just
because there is a raised hand. Okay.
No, I say that the Exoclock really has changed my education. I started with ETD, and it's the data quality parameter of ETD. As many others, I said, well, if it's worse than the data quality of 3, that's for the waste basket. And data quality in EPD is basically the residuals compared to the depth of the transits. So if you have a relatively shallow transit and a bit of noise.
But this is practically or very close to the transit SNR that we also have.
Yes.
So it's an important one. Also, we have this, like, if your SNR is less than 3, it means it's not useful.
Yes. But I have seen that in noisy, and I think that the collaborative acquisition is an example of that. Even with noisy data, you can get an extremely clean transit. And I would say that that's one of the strengths of the Exoclock software.
I can say, actually, what I want to mention is that the things that if your right here is bad, it doesn't mean that it cannot be improved.
Exactly.
Yes. And
Having the feedback,
the shortcoming is that the Exoclock software will fit, will force a transit on any data you put.
Oh.
I have had the case that, you know, I was looking for a transit and I didn't find a transit. I had a perfectly flat, low noise, light curve.
Thank you for the comment. And this is why we need some humans in the process, and not everything can be automatic. Because if you tell a code that these are the data, this is the model, the code will try to find something. Always. I mean, you give it an order, please find me the best solution. There will be a solution. It will be the best. That doesn't mean that it is a good one. And that's why we have the reviewers and all the diagnostics.
Exactly. But this is important element because we need the interaction between people. And Georgia, who is also part of our review team and provides feedback, she helps a lot with reviewing the light care. So this is, this is taking time, but then how can you make the process engaging for and educational for the observers? Because we wanted them to learn and do it themselves, like understand what they're doing, not that we are taking the data, okay, we review them, but that's enough. So I think it has potential also a lot for the educational perspective for people that want to learn from that, not just participate. I just I remember that if you had some slides, if you want to share a few words, but I know that.
No, but I mean, first, we are short of time and it's people that probably see most of it this morning.
Yes.
And I want to add about Georgia and the team, you know, reviewing the data. I have been really amazed on how friendly and how fast.
Yes, yes,
So
exactly.
really, thank you.
Yes. But it's amazing because the two of them have interacted online for a year or so, and they met during EPSC for the first time. So it's enjoyable.
Yeah, we have one more review member. He could not be here. It's Adrian Jones. He will be in the meeting next week.
He will be next week.
Yes.
Yes.
So if you don't mind, I think that there are drinks and
Oh,
food outside.
Yes.
We can make a small break before the
Yes.
Of course.
side.
We can end.
One more question about the reviewing. When we started to use the ECD Exoclock.
Yes, we have the review
Yes.
there as well. So actually, need to mention that actually it's more important that all the data, space and ETD as well, they go through the same review process, the same quality metrics, same fitting. So the data are used from ETD. We don't store the data, but we analyze them on Exoclock, and this makes everything homogeneous. Very good point. So it's the same review process, exactly the same.
The last time it was.
I think we can continue maybe outside. Yeah. We need a break before the next
Thank you all
session.
and to the online.
Thank you.